Hello everyone, let's wait a little bit as usually. Okay, I think we can start. As you remember, last time on Wednesday we were discussing the collections, and we were talking about maps. Yeah, map as the collection. And as you remember, the idea is that we have the key and we have the value for the collections of maps. And we stopped on the point that we wanted to use the object as the key, and in the way it is done here, like we define simple class key, for example. Yeah. Define class, then we just want to set up any attributes and use them as use the whole object as the key. So what's the problem? The problem is that in the current way it does not allow us to do it, because it says that class Java yeah, it means that this class custom key is cannot be used as the key because it can actually, as it says here, cannot be cast to comparable class, which basically means that we have not implemented the interface which needs to be implemented to use to use the key as the class because basically why it requires us to do it. So have interface comparable, which needs to be implemented here, and here we need to provide the class to which we want to compare this class, or this object, and let's see, there's the question. Okay. Okay. Let's see. Okay. I think that's from yesterday. But okay. Okay. Let's continue. So. Some strings. So yeah, what's the idea here? The idea is that basically, as we remember, we have collection map with the type. As in this case, that's the tree map we use. But for all the maps, the idea is that the collection needs to be sorted by keys, by key. Oh, Sandra. Okay. Oh, that's a little bit. That's very strange because yeah, actually for 1 month I thought who is Vladimir, who is Jorans, and that was a little bit strange who are joining us, and okay, finally it's clear who is joining us. So before I thought that there are some random guys coming to attend the lectures, but yeah, okay. Okay. So at least now, now we are clear who are these guys. We had two. We had Jorans, we had Vladimir. So now at least we know who are they. Okay. So it's much more clear now. Okay, let's continue. So basically, the idea for map collection is that we have keys and we have values, and the collection by default, not by default, by the design needs to be sorted. So in this case, if we have the object, as you can understand it, we cannot sort the objects in ascending or descending way. I think you can understand why, because in theory we can sort them by the reference as the text, but yeah, it doesn't make sense if we want to sort the objects, because these are the objects. So we need to find a way, to basically to sort them. If we have, especially if we have the custom class, we need to, not special, but if we have the custom class, we need to basically provide the way how this how the object with this class can be how these objects can be compared to each other. Like, so we have one object, we have another object, and we need to find a way which one is which needs to be sorted. I mean, if we sort them, which is higher and which is lower in the sorting way. So, and as this, so that's why we need to implement comparable to the class custom key, which points us that this object can be compared to another object. Right, so and as it stands here, we want to just compare it to another custom key. And again, as it shows here, it must implement abstract method compared to. So let's do it. Yeah, that's, I think, wasn't, or I think I added this last lesson. So basically, yeah, that's here. We need to implement this interface and let's see, integer. Not sure what's integer, because okay, basically we're not really interested why it is integer, but in this case what I want to do, like in the key we have two values, so basically I can concatenate them and compare the strings which will be the results of concatenation of these two keys. So basically we have this like string key 4 equals just want to, for example, I want to concatenate them. This key 2. And so we do the same for key 2, 4, for example. And key plus a bit bigger, okay, yeah, thank you. Marita, because okay. Okay, goes. Okay, 1 moment. Okay. Okay, moments. Okay. So how was that thing? The window. This next to settings. Properties. Moment. Yeah, I'll show you once, but I forgot where was the place. Somewhere. Yeah. Okay, it's comma, and here I have general appearance, colors much better now. Even more, maybe I can switch it this way. And is it fine now, or need to increase more? Okay, yeah. So yeah, and yeah, not this, but here we need to take it from the object which comes here. Let's see. Well, in theory, we can just simply public string get key. Let's see. Enter. Even more without doing this anymore. Here we can just simply return this get key. Yeah, since this is the string already does the implementation of the and yeah, custom key, custom key. Okay, so now it should. Now we can see we have no errors anymore. No errors anymore. But there's actually one. Okay. Well, yeah, there's only one object inside. Oh, yeah, that's fine. So it's even better. And basically, there are no problems here. Yeah. So we have two keys. Key 1, keys 3, 1, and basically we have two keys with the same values. And as you can see, it did not allow us to add another element to the list because it's already here. So how did it work? It just used the compare method. So using this compare method, the program checks if basically, program compares these two keys. And as you can see, it did not allow us to add another one if we simply change at least one element. Now in second object, now we have two elements. We have one element here, and we have another element here. So basically, this is the way how to use the maps as as the tables. So we can have so we can have simply simply have the table, and so we can implement in this way. So this is, for example, this is tree map, yeah, tree map, and yeah, this is from tree map point of view. This is the key, and this is the value. So in theory, we can have, using the objects, we can have the object with the elements. We can have 1, 2, 3, 4, and m columns here. Yeah. With the same approach, we can use the values, and we'll have another bunch of columns, number of columns. Yeah. Can be the same, can be different number of columns, can be one column, multiple. So basically, that's the way how to implement the behavior of the table, the simple table with many columns in the tree map. What was asked yesterday? Why we have key and yes, and I will share the code. I'll share the code after this lesson. So yeah, no problem with this. Okay, let's move on. We'll have more examples later, but for now let's maybe go for the presentation. So yeah, that's about the map. On the different operations here as well. As I mentioned, he said, let's take over. He said that entry set a little bit. So let's use the same example here. Out. So yeah, and yeah, we can see it returns us the set of keys. Like simply, again we have the table, the keys, and the values. And just simply splits this table in two, and it returns us only the set of keys. Yeah. And yeah, you maybe here it is a little bit tricky to distinguish them, because I used maybe if we use semicolon, if we split with semicolons, that would be more easy to distinguish the place where where the new key comes. Right. So yeah, that's about the method. You just simply want to get all the keys. You can use it and oh, I'm sorry. Just my fault, not here. Yeah. So entry sets. Reset, and if we you will see that basically it returns everything everything as the set. So yeah, it returns everything as a simple set. So there's nothing interested with entry set. Yeah, and the last one is values. Last one is values method, which returns basically all the values from the collection. So if you need just to get all the values without the keys, that can be used. And yes, that's about the tree map. Maybe we should have a topic about hash maps. Also, yeah, maybe we can then talk a little bit about the hash maps. As usual, I use this just to distinguish the running class from other class. Okay. So yeah, as you remember about the hash tables. Just wait a moment, let me. Maybe I'll just use the picture from Google, so that would be maybe much better than my painting. Okay. Yeah, I think that's the first one from Wikipedia. It's pretty wow. So, okay, moments. Okay, so basically this is the simple visualization of the hash table. So again, the idea is that we have the table with the keys and the Jesus, right. Okay, so again, okay. So the idea is that we have the keys and we have values. As usually, so that's a simple map as we have in Java. But what's the idea here is basically we have the keys and how can we access to the buckets to the values. So again we have the table with the values, like with the rows. We have thousands of rows, for example. Then what's the idea is we basically want to insert or read something from, or delete something from this table. And the problem may be that for large tables it is quite complicated to, from the program point of view, and it may take a lot of resources to actually read to get the corresponding entry from the table. And how this can be, how can we improve the performance here from the program, make it faster to access the data. And the idea is that we simply use the hash function. So called hash function. That's the function which takes keys and returns the indexes of the place. Like if you have again you have the table with 1, 2, 3, 4, 5, and so on entries, then it using the hash function you pass the key to hash function, then hash function calculates you the corresponding row where this entry is placed. So in this point, since this is the function, it usually takes the same time to get all the values despite regardless the number of entries we have in this table. So basically it can be simple time, like under some number of steps, n steps for example. Then if the table has 10 entries, that will take you that n steps. If the table has 1 million entries, that still will take you, that still will take n steps to access, to read, simply read the right entry. And as I said, for like imagine if we have where can I read, where can I write it, maybe I can explain it better. So if we imagine if we have this simple, standard table or sorted table. Let's talk about sorted table. So as I said, sorted table usually use so-called binary search to access the data. So the table. So usually we split the table in two parts and we search for the right value. But again, it depends on the number of entries inside this table. So if we have more entries, that will take the program more time to find the right place, find the right entry. And of course, for small amount of entries, that will small number of entries, that's not crucial. I mean, you won't notice that it takes at least some time for small number of rows. But if this number increases, then it will take more and more time to actually access this table. But at one point, like if we have something like average reading in computer science, there are so called big O notations, which describe you the time. I think here it's also mentioned. So we have, yeah, like if you simply look to some algorithms, like if we, so yeah, we have algorithms here, space search or search something, then insert or delete, then you'll usually see such things like big O's from something. What does it mean? What does the big O, capital O from something means? It is very simple. Yeah, it's quite simple. We have okay, maybe again do not try to draw. Something. Let's very simply show you the formula for big O. I hope that won't be complicated for you. So at least the idea is that we have two functions, one function and another function f and function g, and we say that function f is the big O of capital O of function g. Okay, if x approaches to infinity, so it means that we are talking about huge amount, about large numbers. Like we usually consider that if x is something very large, then we basically consider this x as infinity. So, and here we have again the function f is the big O function g if basically there exists a constant value m, like in this case, which means that starting at one point, if we multiply this m to function g, that will be for all next elements that will be larger than, okay, we may skip this absolute value because in our case we're talking only about the positive numbers. So basically it means that and in this case, like if we have for example large O from n, it means that starting at one point, like we have one entry, we have two entries, then we have n entries, like imagine we have a huge number of entries, then so if it says that that's big large O from n, it means that starting one point, the time we spent to search, to insert, to delete, in worst case that will be less than some constant value multiplied by n. So it means that in worst case the read the time we spend to search, to insert, to delete is less than some number, some constant number multiplied by n. So in this case, it means that it depends on the value of n, but this is about the worst case. If we're talking about hash tables, we're usually, and maybe about, if we're talking about all the algorithms, we mostly talk about the average time we spend to do these things. And in this case, we can see that it shows large O from 1, which simply means that starting at some point, like if we're talking about huge, large amount of entries, then the time we spend to read something, to search, to insert, to delete is less than some constant value. So that's why. So this simply means that for a huge amount of entries, maybe let me simply use text path. So it basically simply means that starting, so if we have n, so n is number of entries, rows inside the table, and then if, so if n is a huge number, like it's a large number, or it's a huge number, for example. And if n is a huge number, like more than, imagine 10,000 or something like that, then, example, then the time the program spends to access the entry is less than some constant value. Yeah. So that's basically why we use the hash tables, because for a large amount of entries that will be simply less than some constant value. And we are not affected by the number of entries we have inside tables. In worst case, yes, it depends on the number of entries, because there are so-called things like collisions. But in our case, we are not really. I don't want to go deeper about collisions, because that's where collisions are part of a very complicated case where there are so much numbers of entries that the hash function cannot really produce you this one-to-one relation, like a relation from keys to the position of the rows. So yeah, that's about hash tables, and hash maps thus pretty. Yeah, it works in a pretty simple way, not in a simple way, but in a similar way, like tree maps do. I mean, from the user point of view, from the developer point of view. But under this this structure, there are some differences, and especially if we are talking about the performance. But yeah, just a simple use the same class. So yeah, we have hash map. Then again, we need to declare the key and the value. Let's just have a simple case. Then the key is integer and the value is string. And again, we use the constructor. Yeah, we cannot use primitive data type and collections, so let's use the integer and and yes, that's the question. Yeah, certainly we cannot use integer in the collections. So I think I mentioned it once, but yeah. But the idea is that we can only put the object types as the as the as the types in all the collections. So we can use only objects, and we are not allowed to use primitive types. That's by the design of collections. So yeah, that's why. Yeah, and yeah, if you simply want to ask why, because I think that the main reason is that the 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 values, the keys and the values, most about the keys, like in this example, we know that it must be comparable. But for the integer, basically that's the primitive data type. We cannot call any methods from the integer value, for example, integer or byte or char. That's why we need to use dropper classes instead to achieve all this functionality of method calling and such similar stuff. So it's we can simply add it. Again, here we can put values. And again, print out. You can see that in this case the elements are not sorted. Yeah, by keys, as you can see, that's first and secondly, what's the tricky point is that actually please take a look on on the sequence of these elements. Not I mean, yeah, elements of the collections. Yeah. So as you can see here, we put it 1, 2, 3. But in this case, it has such strange sequence. Maybe let's change something here. Let's run the values here. So and then we'll have 2, 1, 3 here. If we want, we have 1, 3 remains the same, but 15 goes to the first place, and the 4 comes to the 15th place. So yeah, that's basically what I told about hash tables. It does not have any clear properties how the values will be stored in their sequence. What is the sequence of how the values to be stored here? So you see that it goes not randomly, but not in the way we put it them, and in addition it is not sorted by keys. Yeah, you can see again that there's no sort on keys as well. So how can we access them? How can we access the values from the collection? So again, we can use simply get, and we need to provide the key as usually. So simply we provide the key. So simply provide the key, we get the value of the element, which comes to is this key. And what else? You cannot use any different way to access the corresponding element. So you cannot simply ask that you want to access this by index, because yeah, you can, but there's actually no sense to try to get by index, because as I already shown you that with this the sequence of how we store the entries, it is practically not random, but not the way we can deal with it. I mean, there are not ways how we can use this sequence. Like it doesn't make sense that we just simply want to get the third element. Why? Because we don't know what the third element can be here. Like if we add something, then it doesn't make sense if we want to get the third element, because again, you can see here that's the third element, and basically we don't actually know where is the place that the corresponding element will be stored, and we don't care about it. Like if we use hash tables, please remember that the sequence in which the elements are placed to the collection will be lost. Right, so that's also the property of hash tables. So no sequence. Yeah, don't talk about the sequence. Just use the keys and get the elements. Of course, you can get the, like for the map, you can get uh, the set, yeah, entry set of values, I guess. You can get the values, collection of values, but as you can see here, the sequence is lost. Yeah, based on how we added them. And that's why please note that you won't be able to use the sequence of how we enter the values. Okay, let's have 15 minutes break and continue talking about collections. Okay, let's continue. Yeah, that's practically it about the hash, hash, hash maps. So these are the main principles about it. Yeah. Let's go yeah, one more thing is that yeah, it allows one null element, which is fine. But yeah, one more thing is slower but thread safe because it uses vectors for iteration over keys. So as we remember, vectors are thread safe but slower than the arrays. That's why it is tasks more time to iterate than axis. Okay, let's move on to the lists. The lists are the, the most used type of the collections in Java. There are several types of lists. Those maybe if we go to collection API, we can see that there are lists, and we have array list, we have vector. What we're talking about, we have QM, which is yeah, that's not the list, that's Q, but yeah, for the list we have array list, vector, and one thing so-called linked list. And what is yeah, basically what the linked list is, and what's the difference between the linked list and array list. The main difference is in the design of the linked list. So it's practically the same as the array list. So basically all the main functions you can use in array list can also be used using the linked list, but there's one thing, one difference in the design of these lists, and how the elements are stored. So if we take a look at a simple picture here, okay, so yeah, here we can see that so there's the head element of the list, which points to the next element of the list. So we have the linkage between the elements is done in the way that from the previous element we link it to the next one. And yeah, we address to the next mode. So we go from one element to another, and this is basically the way how we create the list. Yeah. So as you remember, the array is just array list is just a simple array, which can be changed with the collection. Like if you add some elements, that will increase the size of the array. If you remove the elements from the array list, that will reduce the size of the array in the array list. But in the linked list, it is done in the way that we have so-called thing like container. That's uh, basically the place that class. In theory, we can linked list can work in a way that we have several different objects located somewhere in different places, and we just for each of them we create for each of them we create a pointer which points to the next object, to the next element. So that's the simple idea of the linked list. What are the advantages of the linked list? If you loop, it may be faster if you loop through the elements. And if you want to remove the elements from the beginning, or just beginning, end, or in the middle of the list, that will just simply if you add or remove elements, like imagine what happens here. So you remove one of the element. In this case, we pass. So once we ask to remove this, we replace, we delete this pointer to this element, and we simply place this pointer to this element and remove this element from the list itself. So here, and these are the keys. We have 3200. We have 3600, and so these are the keys. And here we point to the key to the pointer to the next address. Yeah, so maybe in this case that's not the key, that's the address of the next element of the list. So if we remove something, in this case we need to pass this this address instead of this address here. That's the idea. If we add something, like we add something here, then okay, it has the value, it has the address, then the address from this one comes to this one, and the address which comes to the new element, basically the address of new element, will come here. And this is the way we'll have the chain of the elements in the linked list. That's why we actually don't need to resize anything. We just have the linkage between the elements. We don't use the arrays. We don't we don't need to resize the array. We don't need to create new array. We just simply need to have the pointer to the next element, and that's practically it. Yeah. So I think you got the idea. And what are the disadvantages of this approach? The problem is how you want to. First of all, like here you have the element, which is the object, and in this case we need to store two more values for this for each element. It means that we need more memory to be used for for every element. That's first, and the second point is that basically the way this chain is constructed, like again, imagine you have the chain, and you don't see this chain, yeah. Like imagine you have the chain, and because the program does not really see all these elements, like you cannot. The program cannot simply look to the memory and see that how this chain is constructed. For the program, from the program's point of view, you need to basically use these references to these pointers to the next elements, to the next nodes, to actually to get them. So in theory, you want to read something, you need to go go through the chain. Yeah. So you start at the beginning, then you go to the next, to the next, to the next. So there's no way you can simply use any logical algorithm to maybe find a different way to search for the particular element. You only can go from the beginning to the end, and in worst case you need to go through all the elements, which will obviously take time, and especially if there are huge large amount of entries, then that can be very serious. But yeah, for the array list, that's practically the same. Yeah, for the arrays you also need. But again, the problem is that you need to access them, so it's much more easier to access the array instead of accessing the linked list. Because yeah, in the array you just simply need to provide the index and you get the element. Here you don't have the indexes, you have the chain. And you need to go from one element to another, which is slower than corresponding thinking array. I hope you understand this concept why it is so. Because again, in array we just simply have 1, 2, 3, 4, 5, and then we go through each element. Here we need to read the linkage to the next one, then we need to find this element, then again need to find another element, which is harder than simply go 1, 2, 3, 4 some elements of the arrays, the array list. And yeah, that's about the advantages and disadvantages of the linked list. But in general, yeah, maybe let's use the code to simply go through them. So yeah, we also linked list, and yeah, comparing to the maps, we don't have the keys here, so we simply need to run the type as usually. chapter. Okay, and yeah. And yeah, here are the simple methods. Everything are the same as for the array list. There's nothing special, nothing really special here. One. Simply add the elements then. Right this way. Yeah. Yeah, and you can see we have the same sequence as it is placed here, so nothing really. So everything's practically the same as for the array list. And then you can also access using the index. So nothing really special here. Okay, we can move on. So yeah, indeed. So when do you need to use linked list? I think it depends on you. I mean, on your way of thinking. Like if you really understand why this will be faster for your program. I mean, if you have the case where you when you don't use the complicated search for the elements, you just simply to go through the list. Like if you go from beginning to the end, that's really fine. So have the correct import here. Okay, and everything is the same as here. List. So you have everything. Let's check. That's a little bit. That's a little bit strange. Maybe that's because of some Java versions there. Can you use yeah. So basically that means that you have different linked list imported in somewhere inside. So basically what you can do, maybe you can skip this import here and try to use this way. So if you skip the import, So that's the equivalent approach. Yeah. So I can try this way. That should not. That should fix the issue. Because again, how the import works, you basically point the program which maybe about imports. That's I think that can be really important. That's why maybe let's have a short example about the imports, because that's a really important point, and there may be different conflicts here. Like test import 1, for example, and then we can have test import. So we create two packages. We create two packages here, and imagine that in every package we want to declare the same type, same the class with the same name. And display name. We don't need well, the point, because I'll just use these classes instead to be called from web instead. Public static display name. We have one object here. Then we can do the same with the test import, but change the implementation of the class. So again, class with the same name. So since this is a different package, that's fine to okay, let's use name 2 for example. It's fine if we have the name, so the classes with the same names in different packages, so there are no conflicts. And like if we have and like from here we can import this import. Okay, here we can import everything. Then simply here you can use display name. What was the name for the class? You just created a display name. Then simple display name. So we have the class from the first import. Here that will return us the result from the import. The import one. Oh yeah, we have name. Yeah, that's okay. We have name 2 in import 1 and name 1. But yeah, that's basically the idea. So since we imported the first one, that was called from that package, from package test import one. If we import test package two, that will call the logic from test import two, and we have different implementation executed. So yeah, that's about importing. And if we have two different imports, we have no conflicts. We have no actual conflicts here, but here it shows the error because it does not understand which package should be used. And in this case, I think we cannot really use control space. Yeah. Okay. Okay, it's not straight. But in this case, we need to, and it shows so that's maybe a tricky point with the imports. So this one shows that we want to import practically everything. But in case we have the conflicts with the other package, then we need to specify more detailed way what we want to import. Like in this case, it shows that I want to import the exact path from this package. If like again, if I do it this way, that results in the conflict because the class already exists here. It is already imported. So yeah, and if you have different classes, if you have the classes from the different packages and you want to use them, you can basically control space and provide the package name, then you provide the class name. And you call this one. So that's the way how you can deal with it. Yeah. And you'll have different results here. Right, so yeah, in case you have the conflicts, you can use this approach. Right. Okay. Let's move on with the lists. So total head, I think we already gone through all the lists here. There might be some properties. Yeah, that's order collection, on sequence, and it may contain duplicate elements comparing to the maps. Like in maps, you cannot have duplicate keys. In lists, you can actually have duplicate elements. Yeah, there are the operations, positional access, based on numerical positions, to get something, set something, add all, and remove. So maybe let's simply you need to provide the index. Where was the example? Maybe let's use linked list. So you can use add, you can use get, and you need to provide the index to get get the corresponding element. But get all, and get all set all. Set all. Not add all, sorry, yeah. Add all, then you need to provide another collection, so that will add the elements to this collection. Okay, what else? You can search for a specific object in the list. In this case, it's index off. That will basically provide the element. Oh yeah, and it starts from 0. Yeah. That's the CD. Yeah. It starts from 0. Then using index of, we can find the position of the corresponding element. Yeah. This can be used like in a simple way. You have the list of like you have competition, you have the participants, then you simply want to, and the participants are ordered in the way how they finished. Like if this running, then so there comes the list of those who finished the distance. At the end, there's the list starting from the first element who came first, and go one by one. And like if you want to find the place where it's the particular participant, you can use like index of, as I mean. And like since this is the list where you can add duplicate entries, so we can simply, yeah, if you call element index off, that will return you the first occurrence of this element. If you use the last index of index of, that will return you the last occurrence of this element. First, the fourth one. And yes, that's about these methods. You can use the iterator. It's the iterator. Then you can get the list iterator from the list, and basically it's most likely this. It's usually used this way. Check if it has next. Next. And we'll simply write out the current element. So we'll print it here, for example. No, sorry, that's not correct. Yeah. So why did I do it this way? So just print out this one. And yeah, it points out all the elements here. So next you get the next element, and why you need to provide the type here, because basically, like in this case, you need to know, the compiler wants to know what's the type of the element to be used here. Okay, that's pretty clear. We can move on. So what else is here? Iteration, yeah. Range the subwist method. The range operations on the list. It's not really important for us. Then yeah, most recent implementations, as I said, array list and linked list, most will be most used as array list, at least we used it most. Just basically, yeah, that's the most simple structure of the lists. That's why we use it. Okay, then let's move on to the sets. So that's the collection. That's the list that cannot contain, not the list, but as we can see here, it's not exactly the list, but it's quite similar to the list, which cannot contain duplicate elements. Yeah, maybe let's go through some of them. Okay, maybe let's finish the theory then. Check these the sets. Yeah, so yeah, interface contains only methods inherited from collection, and that's restrictions. Duplicate elements are prohibited, and what we can use here is tree set, which is basically the sorted set. Yeah, you can see here it's under the sorted set, so it is always sorted. Then we have the linked hash. You have hash set and you have linked hash set. And yeah, for hash set to ensure that equals and hash code methods work properly. That maybe let's pose some examples here. So we start with correlation. So I need to provide that. Maybe let's use the string. String. Then what we can do, we can simply again add the elements, the same way as we do it for the lists. Okay, maybe let's use the element part 3. So, to not overcomplicate our imagination here. Simply add something here, maybe try to add duplicate entries. Let's see, maybe next their sequence in some way. Okay, so we have added them. Yeah, just simply point it out. So yeah, first of all, what we can see that duplicate entries are not allowed here. So we have only 1, 2, 3, 4, 5, 6. And yeah, that's maybe a little bit very crazy point, but actually we can see that elements are sorted in the descending way, which is which may be a little bit strange, because yeah, in fact we added in the 1, 2 like in this way, but it resulted in the maybe from the descending order. Okay, maybe if we add some complete elements. Just something like this. Yeah, just mix of the elements, then we can see that it is not really sorted. Okay, maybe let's just if we talk about sorting, let's simply add the elements here. You need to simply understand the way the elements are stored here. Like we have some and just so okay, run. Okay, and yeah, finally we can see that there's no actual actual uh, uh, way how can we determine the right sequence here. So as you can see, it goes practically randomly. That's that's so yeah, that's same way as it is achieved in the hash maps. We don't have any regularity. Yeah, let's go this way in the way how the elements are stored in this particular list. So since this is the hash list, it hashes them, and you cannot really understand on which position your element, not your element, but the element you placed will be stored. That's yeah, that's again the idea. What are the elements here? Yeah, again we can add something, clear everything. We can use the iterator, but again, actually there are no any many ways you can determine the sequence in which the elements will be stored. Okay, I think now we have to break, and after the break we'll continue with the sets. Okay, we can move on. So yeah, what we discussed the elements. Yeah, the features of the hash set in Java. Yeah, what are the advantages this this way of using the sets? The advantages is, yeah, as for all the sets, they don't have duplicated elements. That's for first, and second one is, yeah, you can add the new element, which is also allowed, uh, and if you want to call the method, not call the method, but check if the element exists. Yeah, you can use contains. You can simply search for the element. In this case, returns true or false. Then that for large collections, that that will be much faster to search for the elements than using the tree set, for example. What else? There is also the hash code, which returns the hash code of this particular set, this particular collection. Yeah, that's the unique value for this collection. But yeah, maybe it doesn't really explain you anything, but that's basically the value stored for as the hash for this particular collection. But yeah, basically there's, at the moment we will not talk about the ways how this can be used. It's just here you have the array, so basically yeah, that will return you the array of the elements iterator the same way, but again the collection will be stored in not in a sorted way, not in the way we put it here. That's why you cannot really work with this type of set this way. Then you can use linked hash set. Basically, that's practically the that's practically the same hash set, but the elements are stored using the linkage. So we're not really talking about this one. Again, just simply know that there's such a possibility to use the hash set as the linked hash set. Yeah, so this equals it's not really important for us. And the tree set that we already gone through the tree set. That's just simple sorted list where no duplicate elements are allowed. So nothing really special there. We have already gone through it. So the element handling in collections. Collection, as I said, all collections allow to contain objects only. So you cannot store the primitive data types there. Only the objects can be stored in the collections, and to initialize the collection again you need to provide the type to be used there. In a more general way you can provide the object and store any object you want. That would be fine as well. Except primitive data types. Because primitive data types are not the objects. And to store the integers or floats or doubles, you need to use wrapper classes. Again, basically wrapper classes, as we already discussed this, are practically have practically the same features as the primitive data types. I mean, you can cast them, you can add them, just do any operations you want, but in addition you have the option to have the methods. Yeah, we already used lots of methods from wrapper classes, and that's the reason why the wrapper classes are used in the collections, because we basically can compare, we can do such, we can convert them and do such stuff with them. Casting would be necessary to get the element from the collection, like in this case. Maybe let's show one small example here. We can in theory use the list without the type providing. Let's do a simple test. That's the proper name. So in theory you can declare the list and create new, let's just simply use array list. Array list. And it's fine if we escape the declaring of the type, but in this case that would be the same. Okay, maybe try to add something. We can add, since this is the upcasting in this case, so we cast string to object, that's absolutely fine. If we want to get element from the list, that would be downcasting. One moment. that would be one. Downcasting, in this case, we want to get something from this type of list. And we says that it tries to convert object to string. That's why we need to cast it this way. Yeah, same as. So by default, the type of the list is object. So if we declare it this way, that would be absolutely the same as if we skip it. Yeah, by default it goes to object tab. Yeah. Okay. That's why we need to use casting. Or again use generics, and in this case you won't need casting. Yeah, some operations can be used in collections. I think we've gone through most of them. Yeah, like add all. Just simply, if we want to, if we have one collection, then we have another collection. All collections have the same types. Then add all simply adds one collection to another, and that's it. Remove all does the same way. If we have one collection, then we pass another collection, and from the collection we passed, all the elements will be removed from the original collection, like in this case, maybe, yeah. Let's quickly go through them. Let's use string. Why not just keep it as this. So if we have one list, this one, list. So this works for all the collections. I mean, imagine if we have another list. Let's add something to first collection. And let's add something to second collection. Plus 2, 4, 5, 6. That's it. Add all. And we can simply use another collection here. And print. Let's check what goes on the results. Excuse me. So let's run and check. I think it will be so much output to this program, but okay, we don't care about this output. Where is it? Just comment it out. Yeah, here it is. And yeah, as you can see at the result, we have the Let's call it concatenated list. Yeah, since this is the array list, it doesn't check if there are duplicates or not. So there can be multiple elements applied here, added here, multiple same elements, yeah. Then if we want to remove all, maybe else, two for example, then that should remove all the elements from the first list which appear in the second list. Yeah, as you can see, it removed element 3, removed element 2, until we have only element 1 left here. And another operation, retain all. That's the opposite. Yeah, that's the opposite operation here. So we, in this case, it should remove. Everything but what is in the second one. So it should keep the second and third one. So it removes all the elements which are not the first or the second, or which are not on the second list. Clear again, yeah, clear is pretty clear. We just want to remove all the elements. We want to check if all the elements from the one collection are in the another collection, then maybe, yeah, okay, let's check it contains. Well, then in this case that should be false, because so we have 1, 2, 3, and here we have 2, 3, and 6. So the 6th one is not on the first one, and sorry, that would be here, yeah, that would be here. Sorry, step. Yeah, and we can see that there are some elements which are not in the first list. That's why it returns false. If we check it this way, then it should return true. Yeah, because elements 2, 3 are on first list. So about all these operations, clear, just remove everything. Okay, that's about some simple operations. Then there's also the table you can use for to check which are the implementations and which are the interfaces and collections. Yeah, so there's, I think, yeah, as I said, you can find lots of hierarchies like this, which will show you the way collections are implement it and structure it in Java. So here there are some code examples. Maybe we can just simply go through them here. So we have hash set, and we can add. So as you can see here, we do not provide the type of the set. That's why we can add everything to this collection, and at the end we'll have this collection. But okay, this is the hash set. And okay, and here you can also see that the sequence is not the same as they are added. Yeah, that's the idea of the hashing, that sequence doesn't matter for us. But in the array list, if you do practically the same, you'll see that the sequence is just the same as we added here. 1 second, third, then everything else as it is added here. Yeah. So nothing special. Then we come to the iterators. So that's the process when you just sequentially process all the elements. Well, we have already gone through the iterators. So basically most must-have elements are next and has next, which simply pushes us to the next element. To iterate, we use most usually use while cycle, and simply add the condition. If the iterator has next element, we process this next element. And using next, we can get this particular element. Then fourth thing is that we can use list iterator, which is sorted, and can use also previous and has previous. Yeah, that's practically true, and yeah, so just another way to iterate. Yeah, using list iterator. Use simple example using while has next. Check if there's next, then from about list iterators. I think today, I think that today that we already faced that list iterator. So let's maybe short. Yes, we did, but yeah. That so yeah, basically just this one. For example, set collection. Set collection. No, I mean in the tree set. The tree set is sorted collection. So yeah, if we talk about the tree set, I think that it is sorted, and there is order, like from A to Z. That's for the sorted collection. For the hashed, yeah, that's for the sorted. I hope that's pretty understandable. If we have the data, if we have the list of the elements, and we use, so yeah, we just simply have the list of the elements. That's the set, and what are the advantages? The advantages is when we want to again for the set and for the hash set, the main advantage is the reading possibility. And as I mentioned today, for the set, you can check if the collection contains elements, yeah, contains element, and yeah, that's basically the most the only key feature we can really use in the hash set or in the tree set. Because again, the idea is on the way we read them. Again, for that would be faster for sorted. In average, for the sorted list, that would be faster to read, to find the corresponding elements, right? Let's see if the element is sorted. If the elements are sorted, if the lists, okay, let's call it the list, the collection, yeah. If the collection is sorted, then it is much easier to find the corresponding elements. The same for in average. The same for the hash if there's a large list of elements. Again, as I said about hash tables, for the if we just simply have the list of the elements, and that would also be faster to find the corresponding elements. So basically, the advantage in real life is that if you just simply want to check, if you have the collection where you just simply want to check, store the elements and check if the element exists, then for large lists it is much more better to use hashed set or tree set, yeah. So that's basically the way and the advantage of these sets. Also, there are some technical things like the way these collections are stored in the memory, but in our case it's not really important. But basically, from the practical point of view, we can think about the way we access these elements. I mean, if we want to find something from the collection. And again, for this purpose, we can use the advantages of hashing and sorted lists. That's why we can use them. Yeah, about list iterators. Maybe what else? Simple example. List iterator. Can provide the type. List iterator equals. So not here, but we can get it directly from the list. Excuse me. And then again, the same way, while list iterator has next, then we can get next. Oh, okay, yeah. Okay, we can get next moment. Excuse me, just now we get elements. Get the element and get that next one. Next one. Yeah. And okay, so here now then that will go to the old elements, and one more thing what we can do is to, as that was stated in the presentation, that we can get the previous one. Yeah. So in this case we know that previous does exist. So we can simply get this previous one. That's the advantage of most iterators. So you can see that will add. Oh yeah. So excuse me. This one. Yeah, because the okay. So what do we have here? Here let's simply do it this way. Previous. Okay, so element 1, 2, 3. Okay, so no, well, yeah. How we can show it in a better way? Yeah, this will be the better way. Yeah, as you can see, it goes to the previous one. And in theory, yeah, just a little bit about the usage of previous one. Like in theory, you may think about why do we really need this previous if we just simply can use next one. The idea is that like imagine you have the entries. Like if this is the list somewhere in the document, for example, I have document with the entries, and it is shown nowhere that this list is sorted in some way, for example, by adding date, like you simply want to, and basically what you want to, you may consider that your entry in most usual way, I mean in most usual case, when like you search for, you have the list somewhere in the document or anywhere else, just you're working with, and you assume that the entry you are searching for is usually needs to be somewhere at the end of the list. Like by the design of the program, you may assume that it is most likely that it is somewhere at the end. Yeah? It is not stated that it should be exactly at the end, but it is most likely that it is somewhere at the end. And for this purpose, you can do it this way. Basically, yeah, in this case, we just want to go from the from the end to just from the end to the beginning, and I think it is so yeah, using list index list iterator, it is not possible to go directly to the last one. Okay, yeah, maybe not in this case, but yeah, maybe in other cases, in other interfaces, if you have the list and you want to go from the, like, you may consider that your entry will be somewhere in the end, then you can use the previous one. Or yeah, just yeah, for example, in this case you have the list again, not in this case, but in a similar case to this one. You have the list, like you have the logic which, not this logic, but maybe more complicated logic which adds the elements to the list. Then you will have the logic to add the element, then you simply want to pass these elements after that to some other places, or to print them, or to just simply push them in the order from the end to the beginning. And in this case, you can use the previous method as well. Yeah. That's the idea. I think it's not really complicated to imagine the cases where the previous method can be used. Not only in Java, but I mean in the programming itself, when I'm talking about iterators. Because iterators are used in different programming languages, not only in Java. And the design of the iterators can be different in different frameworks we're working with. And yeah, so this is the hierarchy. Some basic methods. In addition, the list iterator you can set, you can add, and use previous and has previous. Has previous methods, but there's there are some interesting things about these two methods, add and set. Maybe let's just because yeah, if we're talking about the iterators in general, not only in Java, but I mean in general, the idea is that we go through the collection and we do some stuff, right? But in case, like, imagine if we want to add something to this collection. So, like, imagine you go through the collection and you, somewhere inside this iteration, you add something to the collection. So, in this case, you may think about at which position the element is added, how this will what element will be next, like the one I just added, or the real one which was considered to be the next one. So in this case, if you change the collection during the iteration, you need to be very careful about the actual way this this collection is changed. So like here, if we skip this one. Maybe let's skip this one and add maybe something. So there's that. Sorry. Elements plus just to distinguish them. At the end, let's just print it out. So again, we can see that we have the iteration and we add something during this iteration, which may be a little bit tricky. We think about the sequence of the actions done. Okay, maybe, yeah, first of all, let's think about, yeah, so there are no errors here. Let's run. Yeah, and as you can see, yeah, first of all, we can see here that's object-oriented programming, because yeah, here we have the list of the elements, we get the iterator, and we don't touch list one here, so it uses the reference, and it adds the the elements inside this iteration process. And like in this case, it goes in a simple way. It does not, so like it has the first element, then it adds another element, and it goes to elements 2. So in this case, it works this way. Because yeah, imagine in theory you can have the designs of iterators, maybe not in Java, maybe somewhere else implemented, maybe in Java, but using different ways of iteration, different iterators. Like again, what was the problem? What is the problem I was talking about, which may be in some iteration process? Again, I hope you understand it. If we have, so we go through the list, through the collection, we have the element, so like we stop on first element, and then we add some new element. And basically the question is, what will be the next element of this iteration? Like in theory, if we are on the first element, then we need to go to the second element, which is this one. Right, but in this case, if we add something, in theory that may go to the endless loop, right? Because we add something to the first element, then we go to the second element, then we create new element, which will be the third one, and yeah, in this case that may go into trouble. Yeah. But in Java, as you can see here, the iterator works in the logical way that it just simply it skips the element which is added and goes to the initial next one. Yeah? And if you want to use the set, let's check what will be here. We use the set, and then it's just simply changes the current element. And in general, also Yeah. Since maybe it's just a little more tricky process, let's add and remove. So as you can see, there is the remove method which removes the character, but in this case I think that we should have the same result as we do here, because it shows that the statement is legal. Okay, the state is illegal. Okay, but if we do it this way, yeah, in this case it provides actually. Yeah, so in this case we need to understand what is the right sequence here, correct sequence, because if we place the remove after we add something, it does not really understand which element needs to be removed. But here again it removes the initial element from the collection and adds another one. It skips it during the iteration. So yeah, let's need to be careful here. Okay, just a few points here today to discuss. There are a few slides. Okay, not sure if we will be able to go through them. But okay, I think we already discussed the queue is okay. There's also the queue. Not sure if we will be able to discuss these topics today, or we can just simply move them to Monday. Because in the moment I want to, as usually, have the question answer session, so we'll discuss all the things. Okay, now is typing something. Let's see. Christina technique. Just let's see your opinion. Homework for next week. Okay, maybe we. Yeah, we had Q. Yeah, we had Q. We had Q. Okay, maybe then we can just simply. So yeah, I think I explained the main principles of Q. So, yeah, the homework for next week. No, the homework for next week will be. I mean, until the end of next week. That will be about the collections. And so that's the activity 0 something. That's activity 009, I guess. Yeah, I think that's activity 09. But yeah, until the end of next week as usually. So we will have the whole week for the questions. for the questions, and yeah, maybe I will until Monday I will check what about the extra activities. If you can do some of them or any of them to check. Okay, maybe now let's have again the break, and after the break maybe I will just quickly go through the remaining topics of the collections, and then we'll have again, as usual, question and answer session. Yeah. Okay, let's meet in 15 minutes. Okay, then let's continue and not so sure if we will be able to cover everything, but okay, just with yeah, we are already talking about the QS. Yeah, so basically the idea is that first in, first out, yeah, FIFO, collection buffer for holding elements prior to processing. So there are some additional operations like insertion, removal, and yeah, inspection operation one way. So simple insert for add. Yeah, so want to insert something, we use offer, for remove we use pull, and for examine we use peek, just simple one. Go to sample. Then so if we query here, elements strings. And yeah, there was the hierarchy for queues is that we use priority queue. Yeah, priority queue. There are different processes. Yeah, let's just simple key priority queue. And yeah, we can add again something, or yeah, just we can also use yeah, we offer fall and pick. Let's use simple words, for example. Simple one. Let's print it. Yeah, just print it. Let's test it. And yeah, we can see that the priority comes from the last one to the first one. And if we simply want to get something, yeah, then it goes the last one. Then if we get the element, that should also I think get the excellent we press something. And the element will be the same way, just there's some internal differences we not really talk about. Then yeah, and then if we want to get something from the queue, we can use all methods. And yeah, it takes this one, but yeah, again, that's with a strange why it takes the last one, not the first one. But okay, so maybe I will check it until Monday. Okay, the sequence doesn't really make little sense for me. But on the other hand, yeah, if we're talking about the stack as the way of queuing, then it makes sense because the last one will be the first out. But again, if it says here that the priority is first in, first out, it doesn't really make sense if the last one is picked as the first one. So, but again, until Monday I'll check why it works in this crazy way. But maybe at the moment let's move on. Then there's the collection type called the queue, which uses first in, last out. And that's basically what we have now. I'm not sure why, but that's yeah, we need to import it. And as we can see, the queue is implemented. There's no yeah, there's no deposit shows. Okay, so let's check what are the possible implementations for the queue. Okay, we have array DQ. Okay, and the linked list is also considered as the DQ. Yeah, that also makes sense. If we have the linked list, then it is also type of the queue, because as we know, the linked list actually links the previous element to the next one. So it really makes sense if it is implemented in the way the queue actually works. It still shows the compilation error here. Okay. Yeah, and yeah, from here you can see that it takes the opposite. Okay, so basically in this strange way, we can see that it practically works in the opposite way it should work. I'm really not sure why. Because again, for the queue, you know that again we have queue, first in, first out. From here we have the first one, who is Giannis. Then yeah, the first one is out. But actually, this is the queue, which needs to work in the opposite way. Okay, I'll try to clarify it, but why it actually works in the opposite way? That's a little bit strange. But yeah, in this case, please know that Q and DQ just basically work in opposite way. Yeah. By default, yeah, the Q should be first in, first out. In my case, it works like first in, last out. And the Q works, yeah, the DQ works in general way. It should work like first in, last out, but in my case, it works like first in, first out. I'll try to check until Monday why it happens so, but okay, maybe let's move on. So here there are some coding advices. Yeah, why basically we mostly use list, not the full declared type, because yeah, it's much more easy to switch to different implementation. Like if we have one list, then we can simply cast another list to this list, so it's much more easy to use the same variable, not much more easier, it's possible to use the same variable for different list types, which is pretty cool and useful in most cases. Then yeah, there are some basic methods like sorting. We can sort our list. All the questions can be sorted, but for let's check. I think for hash, hash sets it should not allow sorting, but hash maps and hash sets it should not allow us sorting. Yeah, as you can see that statement, which is in presentation, is not really correct. For once again, sorry. Yeah, for hash, for the hashed design, there's no way we can sort it by the design. But yeah, for most collections like lists, you can use the sorting. And yeah, collection of custom objects can implement custom sorting by, yeah, that's what I was talking about. We need, sorry, excuse me. Yeah, we need to implement the interface comparable to be able to compare the elements, the objects with each other. Yeah. That's what I said, and yeah, comparator also can be used. Okay, you can simply use, yeah, just as an option you can use comparable or comparator. In most cases they should work practically the same. Just, yeah, as you can see, there's some differences in the definition of the methods, but it is not really important. It's not really important which one to use. I think that, yeah, right, comparable is more recommended because it's maybe more general. Okay, then yeah. Then compare means that yeah. So if we have the compare method, have object A, if A is smaller than B, then basically we can imagine that there is a sign between them. So if it's smaller, then it is less than 0. If it's greater, then it's greater than 0. So just simply imagine you have one variable on the left side, then another variable on the right side, and you want to compare something. So just imagine that you have the sign somewhere here, and if A is greater than B, then it's greater than 0, if less than B, that's less than 0, and if equals, that should equal to 0. Yeah. So the same object, then yeah, I agree, that's true. Hash code should be the same as B hash code. That's about the hashed objects. No, Sandra. That basically what is said here. You have the object, you have the class. Yeah, you have your own custom class, and you want to compare. For example, you want to compare this. Maybe let's. I just want to show you the example we were talking about. We already talked about here. Simple test at the beginning of today's lesson. So the simple idea is that we need to implement comparable interface where we provide the type to which we want to compare. And in this case we have the method compare to, which comes from this comparable interface. Then this method has the parameter O with the type provided here. Yeah, okay, so that's fine. Yeah, that's why I'm trying to repeat it now. We have the method which we implement, and basically here we can write our own logic. Yeah, basically whatever we want, we can write it here. And yes, basically we can write whatever we want here. Like if we want, we can return something like 1, which means that this one's not needed. So if we return 1, if that's greater than 0, that means that every time you call the method, every time like you have the every time you compare, so you have some object custom key like object 1, then you have custom key object 2, yeah, so you initialize them, new blah blah blah, equals new blah blah blah, again, yeah, for example, you add some values to them, doesn't really matter. Then if we, like in this case, if we call the method compare to custom, compare to object B, like in the way we implemented it here, that will always result in the that object 1 is greater than object B. Yeah, object B, object 2. Basically because we return 1 here. So based on the logic we write here, that will return something which is greater than 0 or less than 0 or equals 0. So if we have such implementation, like we just simply hardcode 1, it means that if always let's call it the source object will be greater than the one provided in the parameter. If we return, for example, -1, that will go to the opposite way. And if we return, because it means that the current object is less than the one provided, so it returns. It results in this one, and if we return 0, that means that these objects will be the same every time. Yeah. So basically, that's the idea. You can implement your own logic here inside this compare to method. Yeah. So basically, you just write your own logic here. Like in this case, I just simply concatenated two strings, and using the compare to method for the strings, I just simply compare it to another string. Yeah. That's basically the way. So in compare to method, you can write your own logic. See, some typing something. Then objects are compared by their points. Sandra, you basically, if in your custom implementation, you can write your own logic. Yeah. So it's based on the logic you write. Compared by their importance. Actually, it's on you. Yeah, how you want to compare them. But the result will be just simply that you declare that object 1 is greater or less than object 2. Like about the strings, if we talk about the numbers, it's quite simple. Like we just not numbers, but in particular decimal numbers. Like if we have like number 2, we know that that's greater than number that integer 1. If we have 2.56700, that's greater than 2.0.0001, for example. Yeah, we know that for this because basically what we check the integer part, then we check the decimal part. So we basically check every number and compare it this way. Same about the strings. We have two strings, and we just consider that the comparison is used in the alphabetic way. Like we know that A is less than B, B is less than C, and so on. So that's basically how it is defined for integer, for numbers, then for the strings, and for your custom object you can write your own logic, which one is greater than another. If we talk about the importance, it's relatively, because in some cases, yes, that can be compared by their importance. Like if you have the objects as for example, as the employees, yeah, you can compare the employees by their maybe by their skills. Like if we have just for example, we have class employee. Then we want to implement comparable. Yeah. Comparable to another employee, for example. Yeah. And for then we have some characteristics of employee, like just don't want to use encapsulation, like skill level, for example. Skill level. Then sure age, maybe as someone is interested in the age of age, or just simple age. Yeah, and simply if we want to implement compare, like you have the source. The source is the current one, and the target which should be provided here. So yeah, for example, you can check it by the number, like for integer total 1, like you multiply the skill level by, for example, 50, like any coefficient, yeah. Then you have, so you can multiply the parameters by their importance, for example. Age, and the age is not so important, we can simply multiply it, or even more, we can reduce, yeah, from the if younger employees are considered as more important than the older employees, then in this case we can simply subtract the age points from the skill points, for example.